So today we're in 12.1, parallel lines and transversals. Someone raise your hand and tell me, what does it mean for lines to be parallel? Parallel lines. Isla?
It means like they're next to each other, but they can never cross.
Right. So they're equally distant from each other, but they never cross. So like the two double yellow lines in the middle of a road, those are parallel. Parallel lines. So what is a transversal then? So a transversal might be a term that's new to you. Okay? A transversal is a line that would intersect two parallel lines. So it's actually going to cross through both parallel lines. And when that happens, the transversal will create many pairs of congruent angles. And we'll talk in a minute about the three different types of angle pairs, or at least our first three. One of them is corresponding angles. We'll talk more about that on the next slide. Okay, you guys got those terms? Okay, so what I want to do first is point out what's happening here on this diagram. These are my parallel lines. Oh, right here, these are my parallel lines. And this is my transversal that cuts through the two parallel lines. If that transversal was not there, there would not be any angles at all. But because this line right here cuts through the parallel lines, it creates all of those angles. And I can identify three different types of angle relationships from transversals. The first one, they're supplementary angles. Their measures add up to 180. They also share a common side, okay? So they're on the same side of the parallel line or the transversal, and they share a common point, meaning they have to be touching. Share a vertex. They share a vertex, which is just a common point. Okay, so we're going to talk in a minute about maybe one pair of supplementary, adjacent supplementary angles. Let's talk now about vertical angles. All right, this should be familiar to you from what we've already learned. This actually was on your test yesterday. That vertical angles are opposite each other and congruent in measure. So we see angle 2. What angle is vertical to angle 2? Y'all just tell me. 4, because it's opposite. And what happens is those angles are equal. They're congruent in measure. Then we have a third type of angle relationship called corresponding angles. These angles are in the same location, but on different intersecting points. So do you see how I have a cluster here up in the top? And then I have another cluster a little bit lower. Do you guys see that? So do you see that 92 is in the top section of that intersecting point? So angle 5 is in the same location on the other intersecting point. So my rule says that corresponding angles will have the same measure. So angle 5 would be 92 degrees. All right? Any questions? Any questions? Let's talk for a minute about adjacent supplementary angles before we move on. Okay? They have to be on the same side of a line. Okay, so do you see how angles 3 and 4 are both on the same side of that line? And they also share a vertex, meaning that they're touching. They share that common side. So that means that their measurements have to add up to 180. Okay, so if I know that angle 3 is 92 degrees, I can subtract that from 180 to figure out the measurement of angle 4. Okay, so you see how they're on the same side of this line. They share the common side, okay, so they can add up to be 180. And now if I know angle 4 is 180, what's angle 2 going to be? 180 because it's vertical. If angle 4 is 88, what will angle 8 be? 88 because it's corresponding with angle 4. So on your homework tonight, it's going to say, explain your reasoning. they want to know what kind of relationship is happening with what angle. But as you can see with the ones we've gone over, is there only one? No, there can be multiple, but that's why you connect it with an angle. It might be adjacent to one, but vertical to another one, and both are true. Okay, and you'll see, again, we're going to do more examples, and that should clear up even more questions. All right, so in example 1, we're going to find the measures of angles 1 and 2 using one of those 3 types of relationships that we just learned. All right, so let's look at the information we're given here. Well, can I prove that anything is vertical to 110? Is anything over here, any numbers over there?
1.
No, not on this intersecting point. So nothing is going to be vertical or adjacent. However, can I connect angle 1 or 2 to 110 by proving that it's corresponding?
Yeah.
Yes. Okay. So I can look. Do you see that 110 is in the bottom left section of the intersecting point? Which angle on the other set is in the same location? 1. So I know that angle 1 is 110 because it corresponds, okay, with the given angle measurement. All right, with the given angle measure. All right, we always have to have that explanation because it proves that we did not guess and we actually knew. All right, so how could we prove the measurement of angle 2? How could we prove that one? I want you to think about it for a second. We need one of those 3 relationships. How could I prove the measurement of angle 2 and find what it equals? All right, both are important. Alexa?
They're on a straight line, so you can do 180.
Yep.
And then you do 180 minus 110, and then you get 70 degrees.
Very good. And when they're on the straight line like that and sharing that side, what kind of angles are they?
Oh, they're adjacent.
They're adjacent supplementary. So it's 70 because it's adjacent, and we can abbreviate ADJ, supplementary to angle 1. Okay? But we always connect it to the angle that it's relating to. All right? So she's exactly right. Is that what you guys were thinking too?
Yeah.
Adjacent? All right, so now on this next one, we're just going to open it up and we're literally going to find every angle measurement. 1, 2, 3, 4, 5, 6, and 7. And for each one, we want to give a reason, an explanation, meaning we're going to say it measures this because it's this kind of angle. So let's start with 1. Angle 1. Oh, and another thing, you can do these in any order. However, you need to know the angle measurement. For example, I'm not going to say angle 1 is this measurement because it corresponds with 4. Well, I don't even know the measure of angle 4 yet. So even though that's true, it's kind of out of order. Okay? So based on the information I know, what would be the measurement of angle 1? Can anybody? Maddie? 75, and why? It's vertical to the given angle measurement. Okay? So you could just say vertical to 75. Since the given angle measurement does not have a number. All right, so now let's just do angle 2. Let's just go in order. Okay, what would be the measurement? I'm going to give you a minute to write it down. What would be the measurement of angle 2 and why? All right, so there's actually going to be 2 reasons or 2 potential answers as to why. Anybody think they might know? Matthew? Okay, so what would the measure be?
105.
Very good, 105 because it's adjacent to 1. That's exactly what I put. All right, so we recognize it shares the same side and the same vertex. and so they're adjacent supplementary. All right, go ahead and find angle 3. Now on this one, we definitely have two potential reasons why angle 3 is the measure that it is. All right, so again, there's not just one relationship that you can prove. But no matter which one you connect to, it will be the same measurement either way. Anybody think they have it? Aiden, Austin, what do you think? Anybody? Isla, what do you think?
It's 105 degrees because it's vertical to 2.
Very good. Vertical to 2. That's what I put. Why else would it be 105? Can anybody give me the other reason that could be acceptable, Joel?
Is it adjacent to, number 1?
Yep, it's adjacent to 1 also. Do you see that? It's on the same side. It shares a vertex. Okay. So it's also, it's adjacent to 1. All right, go ahead and do 4, 5, 6, and 7 with your table buddies. Hey, who wants to give me angle 4? Joel, what you think?
75 degrees corresponds to angle 1.
Corresponds to angle 1. That's what I put too. All right, what about angle 5? Lydia, what'd you put for angle 5? Okay, why? Okay, she said corresponds to 2. Perfect. I put something different. I don't remember what. They said adjacent to 6, which we actually talked about that in the last class. Do we technically know what 6 is yet? No. Okay, so that's okay. But you're going to need to go back and actually make sure that's true. All right, I would prefer what Lydia said, which was it corresponds with 2. Or that it's adjacent to which one have we already solved? 4. Okay, so we could have said adjacent to angle 4, and that would be good. All right, what about 6? What about 6, Aiden?
75.
Uh-huh.
It's vertical to 4.
All right, vertical to 4, and I put corresponds to the given angle. But again, I love the vertical too. All right, so that's great. Or what's the other reason? What's it adjacent to? It's adjacent to, well, it is 6. It's adjacent to 5. Okay. All right, what about 7? What about 7? Aaliyah, what'd you get for 7?
105 plus 115 with 3.
All right, very good. She said it corresponds with 3, which is perfect, and I put vertical to 5, which is also true. Or you could have said adjacent to 6 or 4. All right, so do you see how there's all these different relationships that you could prove? That's why I don't just say vertical, I say vertical to what, okay? All right, so that's really like the core of what we're doing today is what we just did in that example. But we have 2 more that we're going to add into the mix. So we've learned three relationships: supplementary, adjacent supplementary, vertical, and corresponding. And now we're going to throw 2 more relationships into the mix. These are what we call alternate interior and exterior angles. Okay, so the transversal, when it cuts through, it creates interior angles. That's what we see inside the parallel lines. Okay, so do you see this space that's inside the parallel lines? Those are what we call interior. What makes them interior? They're inside the parallel lines. Exterior angles will be outside the parallel lines. I don't like that color. Let me change it to green. Okay, will be outside the parallel lines. So here and here. Do you see why the angles are either interior or exterior? So now what my rule says is that alternate interior and exterior angles are equal in measure. Okay, so whatever angle 3 equals, angle 6 will equal the same thing. What makes it alternate? it will cross over the transversal. It will go to the other side of the transversal. So do you see how angle 4 is on the right side of the transversal? And angle 5, while it's still interior, is on the opposite side of the transversal. Okay? That's what makes it alternate. So now look at these exterior. Do you see how angle 1 is on the left side of the transversal? Angle 8 is on the other side, and it's on the right side of the transversal. So they're alternate exterior. What do I know about them? They're equal in measure. So if I know angle 1, I can go directly to angle 8, and I know what angle 8 equals. And that's what we're going to do in the next example. All right, are you somewhat following what I'm saying?
Yes.
Interior, alternate interior, and exterior. Okay, so let's look at this airport runway. Anybody ever flown in a plane? And you go out to the runway, they're taking all those turns, okay? So that's what this picture is, okay? It's a portion of an airport. And on this diagram, we want to pick out our angle relationships. Let's start with alternate interior. Okay, we'll abbreviate. I need one pair of alternate interior angles. So I look at the parallel lines. Alternate interior will be inside the parallel lines and on opposite sides of the transversal. Anybody think they could possibly give me one pair? Alexa?
Angle 7 and angle 2.
Okay, 7 and 2. Do you see how 7 and 2, they cross that transversal, but they're both interior? So 7 and 2 would be 1. Angle 7 and angle 2. That's one pair. Hope, what would be my other pair of alternate interior? Okay, angle 4 and 5. All right, what about alternate exterior? Alternate exterior. Anybody think they know? Colin?
Angle 1 and angle 8.
Yep, angles 1 and 8. Now, it won't always be, oh, well, there's 8 angles, so 1 and 8 are always. They might switch up how they number them. But we did see that 1 and 8, yes. And what's my other pair? What's my other pair, Hadley?
Angle 6 and angle 3.
Yep, 6 and 3. All right, so now let's go back to our other ones. Can anybody give me one pair of adjacent supplementary angles? Can anybody give me one pair of adjacent supplementary? So we're bringing back our first examples. We're going to bring it all together in this one. Isla, what do you think?
6 and 8.
6 and 8. Do you see how they're on the same side and they share the common point? Okay, so angle 6 and 8. There's actually 8 pairs, guys.
Yeah.
Was anybody thinking a different pair? Okay, there's actually 8 pairs that you had to choose from. All right, we just chose one. What about a pair of vertical angles? There's only 4 pairs of these. Can anybody give me a pair of vertical angles, Janice?
Angle 1 and angle 4.
Okay, she said 1 and 4. Do you agree?
Yes.
Yeah, that's definitely one pair. Maybe you were thinking in your mind a different pair? Because there's 3 other pairs, right? 2 and 3, 5 and 8, 6 and 7. All right, so we have vertical. The last relationship would be our corresponding. Okay, can anybody give me one pair of corresponding angles? Trying to call in everybody. Kalani, can you give me one pair of corresponding angles there? You see one? Corresponding? All right. What you think? Yeah, perfect. 3 and 7. They're both in the bottom left. Angle 3 and 7. They're both in the bottom left section. Okay, very good. Colin?
Angle 1 and 5.
All right, he said 1 and 5. Do you agree with him?
Yes.
They're both in the top left. All right, which one matches with 2?
6.
6. And which one matches with 4? 8. And again, 4 and 8 don't always match up. They might have completely different numbers, okay? So don't think it's always going to be just those two numbers together. It just depends on how they set them up. All right, last example. Oh, I forgot we were going to do the think, pair, share. We've got time. Go ahead and find these 3 angle measurements. If angle 4 is 84 degrees, what would those 3 angles be? The explain your reasoning is to give me some type of relationship to another angle. So does it correspond with an angle? Is it vertical? What is it? Okay, so don't just tell me the measurement. You have to tell me why. All right, we'll stop here for a couple minutes and we'll do this one. All right, so here we go on angle 3. And remember, you want to relate it to an angle that you know. Okay, for example, I'm not going to compare angle 3 to angle 7 because I don't know angle 7. All right, and while I do think it should be the same, how angle 7 doesn't help me figure out angle 3 is measured. Does that make sense? Okay, so that can't be part of my reasoning. All right, let's see. Where am I at? Here I am. Okay, so what is the measurement of angle 3? Y'all just tell me. What is it?
96.
Okay, why? Yes, I'm hearing it. Supplementary to the given angle measure. Okay. All right, what about 5? Someone raise your hand and tell me 5. Matthew? Never mind, Patty. All right. Yes. Okay. She said 80. You did say 84, right? Okay. Because it's alternate interior to angle 4. Now, I had someone say that it was corresponding to 1 or vertical to what? 8. But you don't know 8. So then if you say that it's a vertical to 8, but you don't know it, you would also have to say that 8 corresponds with 4. But you've got to say both of those reasons. You have to connect it back to an angle that you knew. Okay? So that's important. I'd say alternate interior to 4. All right, what about 6? You just put it on my desk. What about 6? What about angle 6? Anybody have that one? Angle 6? Anybody different? Any new people want to volunteer? Joel, thanks, buddy.
96 degrees because it's supplementary to 8.
Okay.
We're at 8 because it's alternate. It's corresponding to 4.
Okay, so he said supplementary to 8 and 8 corresponds with 4. That's perfect. Did anybody put alternate exterior? Did anybody do that? Raise your hand if you put alternate exterior. So that's a direct connection. That's a one-step connection to angle 6. That is alternate exterior to 3. It's on the other side of the transversal and they're outside the parallel lines. But what Joel said is fine too. Okay, as long as you have both relationships. Huh? To 5. Okay, so Addie put adjacent supplementary to 5. That's perfect because you already knew 5. Stairs. Okay, now on the stairs, they look a little weird because, like as far as all the lines, because you actually have 2 transversals. Okay, but the lines or the angles that we're looking at, we want these 2 lines to be parallel. How do I know that? It says, at what angles do you need to attach the rail? Well, this is the rail right here. Okay, to the post, these are the posts. The ones that are going vertical, those are the posts. So what angle do you attach the rail to the post so it's parallel to the steps? All right, so what makes it a little weird is that you have 2 sets of parallel lines. Okay, but the process is still going to be the same. We're going to start with our given angle measurement, 45 degrees. Well, this little red box gives us a little hint. What does that little red box mean?
Right angle.
It's complementary. It's 90 degrees. So what does that make angle 1? It makes it 45 degrees. Y'all with me so far? Okay. So my whole goal is to figure out what these angle measurements need to be to set that rail exactly parallel. All right, angle 1's going to help me get there. Okay, angle 1 is 45 degrees. All right, so I'm going to look at these two sets right here because this transversal is cutting through those two parallel lines. You see that? Okay, so how could either angle 4 or 5 relate to these angles? Look at the location. Look at the location. Isla?
It's corresponding.
Yes, which one?
1 and 5.
1 and 5 correspond. Okay? And that's broke my ice right there. As soon as I know that angle 5 is 45 degrees, I can go ahead and solve all of these. Because now I can prove alternate interior, 5 and 6. I can prove supplementary, 5 and 4. Okay, and then I can prove alternate interior again with 4 and 7. I thought I changed my marker. Okay, so if angle 5 is 45, what would that make angle 4? 135. Okay, so that's the angle measurements that has to be here to attach the rail. Now I can use what rule to find angle 7? Alternate interior, because they're inside the parallel lines. So 6 is 45 because it's alternate interior, and 7 is 135. All right. What now? You don't have to know 2 because the steps are already set. The steps are already there. You're just trying to figure out the incline of the rail. So you would say that angles 5 and 6 need to be 45 degrees. And 4 and 7 need to be 135 degrees. And if you set them at those angle measurements, it will be parallel to the steps. Okay, so we just using our angle relationship. You say, well, Miss Kinder, the steps kind of messed me up. All right, well, that's important, but it's not the most important thing about the lesson. Did you understand the 5 relationships that we talked about today?
Yeah.
Okay, that's really important. Now, this is kind of, it's one of those real life applications, and it is important. Okay, but it's really more important that you understand those 5 angle relationships. All right, and that'll be everything for 12.1.